Okay, so today what we're going to do is we're going to begin our really in-depth look at fractions. Most of the work that you're going to be doing in this section centers around fractions in some way. And it's a critical skill. If you can't work with fractions, then you're always going to have difficulty as you move forward, right? Now, I know that you've seen fractions since the beginning of time, right? But that doesn't mean you really know what it is you're doing. Also, many of us develop a lot of bad habits around fractions. We assume things are true that aren't true. We like to use shortcuts that don't really exist. Okay? So we're going to talk about it, and we are going to get the definitive, clear, this is the way it's supposed to be done of fractions. If you already know it, great, wonderful, yay, that's a good thing to be comfortable. But if you don't, this is the time to clean it up, because later you're not going to be taught fractions. This is the last time you're going to have a really good look at fractions. Before now on, after this, it's just going to be work with the fractions. All right? And they never go away, so it's very important that you understand how they work. Okay? So, what we're going to do today is we're going to begin with just looking at some basic ideas of fractions. Okay?
The ultimate disguise.
There you go.
Tree.
I haven't any idea. So the first thing we're going to talk about is something called equivalent fractions. Can anybody tell me what the word equivalent means?
The same as?
It's the same. They're equivalent. They have the same value. Now, does that mean they're identical? No. That just means they have the same value. Okay? So, for example, could you have two $5 bills and one $10 bill and have the same amount of money?
Yes.
Absolutely. Right? Just broken up in a different way, but it's exactly the same amount. And that's how you need to think about equivalent fractions. They can look different, but they behave exactly the same. They have the same value. Okay? All right. So let's say you've just come home from school and there's a huge cake on the bench. And you decide, you're going to cut yourself a piece of this cake. And you decide, just a small piece, maybe a quarter of it. Is a quarter a small piece? No. One quarter is 1/4 of that cake, right? So, well then you're going to have to take 2 quarters then. All right? So hold on a minute. But you go outside of the room for a minute, and when you come back, the cake is cut up into a bunch of little small pieces. But you still want to eat that 1/4 of the cake. You've decided that it doesn't really matter how many pieces the small pieces are. You're still going to eat 1/4 of that cake because it's yours. Right? Okay? Makes sense to me. Well, even though it's cut up into smaller pieces, we can still eat 1/4 of the cake, right? It just means instead of one big piece, we're going to have what? Several smaller pieces, right? So you can always divide fractions into smaller and smaller and smaller pieces, and just having more of them will continue to mean you have the same value, okay? So, in this particular case, each slice has been divided up into 6 pieces, which means that each slice is 6 times smaller than your original pieces, right? You divided it up into 6 pieces, so now they're 6 times smaller. So does that mean you need to take 6 times more? Yeah. If it was 6 times as many, right, 6 times smaller, that means you need to have 6 pieces to make up the one big piece you were going to have before. Yes, ma'am.
So the whole cake would be 24 pieces.
You bet. Right? Because if each quarter was divided up into 6 pieces, 4 quarters would mean 4 times 6, or 24. Good job. Okay. So there are 24 pieces. What fraction? And you're going to take 6. You're taking 6 24ths, right? But from our work with fractions before, we know that we would never leave a fraction as 6 over 24. Yes, you should. That would be perfect. 6 over 24. So even though, all right, so we have the fraction, and 6 pieces out of 24 is actually what we have. We would never leave it that way. We would always simplify it. And you simplify it by simply dividing out any common factors. Okay? So, in other words, what number will divide evenly into 6 and 24 at the same time? 6. So, yeah, they divide by 3, but they could also divide by 6. And if you divide them by 6, that's going to give you 1 over what? 4. So even though we have 6 pieces out of 24, that's the same as saying that we have 1/4 of the cake. And that idea is the most basic idea in fractions. So let's talk about that idea and talk about steps. To simplify fractions, I'm going to use some math words that you need to be familiar with. First, okay, you're simply going to divide away any factors, and that's the math word that we're going to talk about, any factors that are common to both the numerator. Can anybody tell me which one is the numerator? The top number? And the denominator. Okay. Divide away any factors that are common to both the numerator and the denominator. They have to be common to both in order to make this work. Now, let's talk briefly about that word factors. I'll give you a little more time to write those down, because we need to understand what a factor is in order to make this work. Okay? And I'm going to show you in words, and I'm going to show you in an example for factors. Okay? So this should be below. You know, of course, I can't organize it as well as you can. So below this, you should be talking about factors.
Do you have to write it down?
You bet you do. Let's say we had 2 times 4. What does 2 times 4 give us? 8.
Who said 3?
Right? Okay? Well, the 2 and the 4 are factors. And the reason they're factors is because they're multiplied together to give you this number, which is called the product. Remember, I told you you need to learn the vocabulary of mathematics in order to make mathematics work for you. So, the number you get when you multiply is called a what? Product. The numbers you're multiplying together are called what? Factors. Now, is there an opposite operation for multiplication? What's the opposite operation? Division, right? So, that tells us that we can go the other way too. So, 8 divided by 4 gives us what? 2. Okay? Well, these 8 and 4 are still the factors. Right? So we can define factors in 2 ways. Okay? And one of them is just the straightforward, this is what they are. And the other one is how to find them or how to use them. Okay? Go ahead and write that down. And then, because I need some space, I'm going to erase some of this so I can put some more stuff on there. Tell me when you're ready. Okay. We're about ready, guys? Come on. Okay. All right. Here's what I'll do. I'll erase this part of it because that'll give me enough room, and that gives you the other part that if you haven't finished quite writing it down yet. Okay? All right. So let's talk a little bit about factors. Hugely important as you move forward. You're going to learn a lot about factors in your mathematics career. Factors are things...
Do we write this?
Yes, please. Things that are multiplied together. Simple as that. Anything that's multiplied together is a factor. So they're always connected with multiplication. Okay? So, 3 times 2, 7 times 5, a times y. Doesn't matter. Doesn't have to be numbers. Anything that's connected with what operation? Multiplication is a factor. And when you multiply them together, the answer you get is called a what? Product. Excellent. Okay? Now, here's where we reverse it a little bit. Factors are found using division. In other words, if you have the product and you want to find the factors, well, the opposite of multiplying things together is to what? Divide. And that's what we did here in this particular example. We simply took the 6 and the 4 and divided them both by 6, right? We divided out the common factors that were common to both of them. Okay? So, factors are connected with multiplication, but how do you find them? You use division. Make sense? Okay, you do the opposite things to do and undo things. Because really what you're doing when you're using division is you're undoing the factors. Good job. And we're going to talk about this a lot. And as you move forward, especially when you start building the algebra system, you're going to do a lot of factoring in algebra. Or factorization, I think I'll call it. Yeah, I call it factoring. All right, how does that look? Pretty good? So if I ask you what a factor is, you better know what it is, right? Okay. All right. So even though these two fractions don't look the same, they have exactly the same value. They are equivalent fractions. So we're going to spend some time doing that. Here's another way of looking at it. It says there are 4 lots of 6 in 21. So, thank you. So 24 divided by 6 gives you 4. So it's exactly 6 slices to make 1/4 of the whole. Okay? All right. So all we're doing is regrouping them into smaller pieces or larger pieces, but we're not changing the amount of cake we had. You good for that? Okay. So look at this one. This cake is divided into 20ths. What does that mean? 20 equal pieces. Yes. 20 equal pieces. Remember, if you're going to do this, you have to make sure they're all equal, yeah? So the cake is divided into 20 equal pieces. If you take 4 slices, what fraction do you have? Okay, right? Because you have 4 out of the original 20 pieces. But what will divide evenly into 4 and 20? Well, they'll both divide by 4, right? Which is going to give you a 1 in the top and a 5 in the bottom. So they're equivalent fractions. And you must write them in this format.
Do we write that?
Yes, please. Okay? All right? Yeah, anything that I write, you can assume that you should write. Yes? Well, if it turns into a 1, not every fraction will always reduce to a 1, but if it does have a 1, then yes, you must. Okay? All right? So, equivalent fractions just mean reducing them. So there you go. 4 goes into 25 times, so that's 1/5 of the cake left. Okay? All right, so then it goes into your homework. Yay, you love your homework. Good job. Let's see what else they're going to do to you. Dividing up that cake was fun. Well, it's not as fun as if you had a real cake, but it's not too bad. Okay? So, anytime you divide something, you're using a fraction. And this is something that students often miss. Okay? So here, write this down. This is critical. The fraction bar is actually the division symbol. The fraction bar is actually the division symbol. Look at what I mean. Say we have 1/2. That's the same as saying 1 divided by 2. And if you look at the division symbol, you have a fraction bar and you have 2 dots over it. Doesn't it even look like a fraction? Look at that symbol. That looks like a fraction, but instead of numbers on the top, we have dots. Yeah? Okay. And so actually, the fraction came first. The fraction bar came later. It was invented later to simplify it so that everybody didn't have to see fractions and freak out. But anytime you see a fraction, you should automatically think, what operation? Division. Now, in some cases, you can't divide things evenly. So like 1 divided by 2. Can you divide a 1 by a 2? No. And that's why it stays a fraction. But many other times, you can do the division. Let's say we have 6 over 3. Can you divide a 6 by a 3? Yes. Absolutely. 6 divided by 3 just leaves you what? 2. So some fractions will simplify just into whole numbers. Okay? Now you have to be careful though. Look at this one. Three divided by 6. Does that make 2? No. Because 3 is smaller than 6, isn't it? So I can't divide a 3 by a 6. But what can I do to that fraction? Simplify it, right? What will divide into 3 and 6 at the same time? 3. Well, in the top, 3 divided by 3 is 1. 6 divided by 3 is 2. So you end up with 1/2. So be careful. If the top number is smaller than the bottom number, then you're still going to end up with a fraction at the end, right? Okay. Good job. Okay, so let's look at a couple of those. What part of fraction counts as the number of total pieces? That's the bottom number called the denominator, right? Okay. And we can change the divisions into different pieces. So 1/4 we already know is 6 out of 24. Okay? All right? And if you look at this shading here, you can see that even though they have different values, they are exactly the same amount of cake. Right? So we can change them all the time. Okay? Good deal. So you don't change the amount of cake. Okay. I'm going to tell you one thing right here. Do you see that little expression canceled out? I will make very, very unhappy faces at you if I see you say that.
Oh. Cancel out.
That's one of those shortcuts that causes students a lot of trouble. They don't cancel. You can divide a number by another number, right? But does that make it cancel? No. If you cancel something, that means you throw it away, get rid of it, don't you?
Like the brackets.
And that's not going to happen. Okay? You can use something, but using something is not the same as canceling it. Okay? If you go to a concert and use your ticket and see the concert, did you use your ticket? But did you cancel the concert? It's not the same thing. Using something and canceling something is not the same thing. I hate that. Well, you use them, right? So they don't cancel. They're just gone because you've used them, right? Things do go because you've used them, but that's not the same thing as canceling. I hate that expression, and I'm sure that every one of you learned cancel. And it's a really dangerous thing to think of. So be careful. Don't use shortcuts that cause you trouble. Right? It'll only make your life worse as you go. Now, can anybody think of why math teachers might want to say cancel? Who does that make it easy for? Yeah, it makes it easy for us to say cancel. Because you can see here, we can say, oh, those sixes cancel.
Wait, so you want us to...
Right? But does the 6 cancel? What does 6 divided by 6 make? Anything divided by itself makes a 1. But 1 times anything is the same thing you started with. So it looks as if things are disappearing, but in reality, they're not. Anything divided by itself doesn't cancel. Anything divided by itself makes a what? 1. But if you have a 1 times 5, you still get 5, right? So it looks as if the factor is being eliminated, but it's not. So be careful. Now, I know it's a habit of a lifetime, so I'm not going to yell at you, but I'm telling you, life is better if you don't. Look at these two fractions. We want to say that these two fractions are equivalent, but what do you notice about one of the numerators? We have the whole fraction there. We have the 28 in the bottom there. But we're missing one of them, aren't we? Okay? Yes, please. All right. But we're missing one of the numbers. Well, but if they say equals, that means those two fractions have to be equivalent, right? Meaning that they have different numbers, but the value is the same. So all I need to do is think about what did you multiply 7 by to get 28? All right? So that's your first step. Yes. You bet. Absolutely. 28 divided by 7 is 4, isn't it? Okay. So the second step is to simply multiply 3 times that, I can't spell, that same number. Because remember that if they're going to stay equivalent, we have to change them in exactly the same way. A while ago, we made them smaller by dividing. This time, we're making them bigger by using, not division, but what? Multiplication. So 28 divided by 7 is 4, and 4 times 3 is what? 12. So those two are now equivalent fractions. So if you're missing one of the numbers, very easy to find the other one by simply just dividing and then multiplying. Okay? So ask yourself, what did you multiply the 7 by to get the 28? And then you multiply the top number, the numerator, by exactly the same number. So let's say I had, for example, 5 over 15 equals something over 30. So I'm missing one of the numbers. What tells me that these two things are the same fraction? The equal symbol. Very good. Okay. So all I have to do is find out, what did I multiply 15 by to get 30? 2. Well, that means I have to multiply the top by exactly the same thing if I want to keep them equivalent. So 2 times 5 gives me 10. So you're just going the other way. So instead of dividing to make the numbers smaller, you're multiplying, which is going to make the numbers bigger. Okay? Yes? That. It's supposed to be that. Yes, please correct me and make sure that I write neatly. Sometimes it's not as easy on this thing, you know. It just slides all over the place. But it slides all over. It's on glass.
It's like almost the texture of writing on a whiteboard.
It's on glass. It makes it harder. Okay? So then they show you how many lots and then you go through. So there you are. You've got some more homework there. Now, let me go ahead and